Hi everyone. Here question is conversion of epsilon NFA to DFA. We have given epsilon NFA here that we need to convert to DFA. For this we will follow the two steps. As per the process, first we will find out epsilon closure of all the steps, and in the second step, using epsilon closure of all the states and using the subset method, we will create new states for the required DFA. So let's start. The first step is finding out epsilon closure. We will write here name of the state and its epsilon closure. How to find epsilon closure of any state? For that you can refer the last video, link is given above. How many states are here? Q0, Q1 and Q2. So write down it Q0, Q1 and Q2. Epsilon closure of any state is nothing but a set of states including itself. For example, here epsilon closure of Q0 is first Q0, similarly here first Q1 and similarly here first Q2. Then Q0 epsilon closure, wherever Q0 is able to reach using the epsilon transition. For example, Q0 is able to reach here to Q1 using epsilon transition. So write one here Q1. Then Q0 is able to reach to Q1, Q1 is able to reach to Q2. So write down here Q2 also. So this is what epsilon closure of Q0. Similarly, epsilon closure of Q1, Q1 itself, comma, Q1 having epsilon transition, it can reach to Q2. So here Q2 also. Then Q2, epsilon closure of Q2, epsilon closure of Q2 is Q2 itself and there is no epsilon transition, so it only contains Q2. This is the first step. What's the second step then? In the second step, we are going to find out transitions and states of required DFA. For that, the first thing, whatever is your starting state in the given epsilon NFA, here is a Q0. What's the epsilon closure of Q0 is? Q0, Q1, Q2. What you need to assume here, so let's understand or let's consider that epsilon closure of starting state. What is the starting state? Here is a Q0. So epsilon closure of Q0 is our starting state of DFA. Let epsilon closure of Q0 is starting state of DFA. What is epsilon closure of Q0? Epsilon closure of Q0 is Q0, Q1, Q2. So Q0, Q1, Q2 becomes our starting state. So let it draw here parallelly. If I draw here, for example, Q0, Q1 and Q2. This is our starting state. Now we got starting state of our required DFA. Now we have to find out its required transitions. For example, here input set consists of A, B and C. So we will try to find it parallelly. Then delta means what? Transition function Q0, Q1, Q2, where it goes on reading A. Because I as already said that let's assume that epsilon closure of Q0 will be our starting state. That is nothing but Q0, Q1, Q2. So if this is the starting state, so on transition of A or after reading A, where the starting state will go, that we need to find out. So how to find out? Delta Q0, Q1, Q2 on reading A. This also we need to find out using the epsilon closure. For example, we will write here epsilon closure of. You need to write down same thing there itself. Delta, then Q0, Q1, Q2 on reading A. This is as per the subset method. We will find out new subset or new state. So this is very simple. Epsilon closure as it is. Then delta Q0, Q1, Q2. Here we are going to find out new state, new subset for the required DFA. But for that we will be referring the existing or given epsilon NFA. So Q0, Q1, Q2 on A. It means Q0 reading A. Where it's going? Check the existing epsilon NFA. Q0 on reading A. So Q0 on reading A, where it's going? It's going to Q0 itself. So write it down here. Next Q1. Q1 on reading A. Q1 on reading A. Q1 don't have any transition for A, so there will be nothing. Then Q2 on A. Q2 also don't have any transition for A, so there will be only Q0. Now we know epsilon closure of Q0. What is it? Q0, Q1, Q2. So I am writing here Q0, Q1, Q2. Even here in the epsilon closure we have given comma Q0, comma Q1, comma. Here it will be considered as only one state. I have explained this in the conversion of epsilon NFA to DFA. What is the meaning of subset method? We are creating here subset, and even though these states looks different, separate one, but this will be only one state in terms of DFA. What is the meaning of this first step? It says that delta means transition function. This is the new state that we consider at the very beginning. This new state on reading A going to this state. Here it's the same state. It means what? Q0, Q1, Q2 reading A going to Q0, Q1, Q2. It will be a self loop. So give the self loop here. Then what? Repeat the same process. This is for transition for symbol A. Then same you need to repeat for symbol B. So Q0, Q1, Q2 reading what? B. Then same process Q0, Q1, Q2 reading B. Epsilon closure of delta Q0, Q1, Q2 B. Repeat the process Q0 reading B. Do we have transition for B from Q0? No. Then Q1 reading B. Q1 reading B. Yes, it's going to Q1 itself. So write it down here Q1. Q2 reading B. We have transition? No. Q2 don't have transition for B. So epsilon closure of Q1. What is it? Q1, Q2. So write it down here. Q1, Q2. It means what? Q0, Q1, Q2 reading B going to new subset Q1, Q2. So write it down here parallelly. Q1, Q2. For which symbol? Symbol is B. Repeat the same process for transition for symbol C. So write it down here Q0, Q1, Q2 on reading C. So Q0, Q1, Q2 on reading C. First Q0 on C. Q0 don't have transition for symbol C. So nothing. Then next one is Q1, Q1 on C. There is no transition for Q1 also. So 5 means null. Then Q2 on C. Q2 having transition for C. It's going to where? Q2. Then epsilon closure of Q2. What is it? It's Q2 itself. So we can write here Q2. It means what? Q0, Q1, Q2 on reading symbol C. It's going to new subset or new state Q2. So write it down here Q2. For which symbol? For symbol C. This way, for the starting state Q0, Q1, Q2, we got transition for A, then B, and then C. Similarly, now whatever the new subset or new state, for example Q1, Q2 or Q2, for these two states we will find it out. You can repeat the same process. What is the first state here? First subset Q0, Q2. So we can write down here Q0, Q2. And the same symbol, symbol A, B, C. So Q0, it's a Q1, Q2. So let me write it down. So new subset is Q1, Q2. So delta Q1, Q2 on reading A. So epsilon closure of delta Q1, Q2 on reading A. So Q1, Q2 reading A. From Q1 there is no transition for A, neither from Q2 we have transition for A. So there is no transition for A from Q1, Q2. It means what? It's going to nowhere. We can say 5. 5 means our dead state. Epsilon closure of dead state is dead state itself. It means what? From this new subset, transition of A will go to the dead state. So let it write down here. You can write down 5 as it is, or you can write down dead state also. If you remember, in DFA only we used to draw this dead state for the symbol A. Now repeat the process for symbol B. For the new state, transition for B, where it will go, that we need to find it out. So for symbol B, epsilon closure of delta Q1, Q2, comma B. Q1 going on B, Q1 going on B, going to Q1. So write it down here, Q1. Q2 on B, Q2 is going, there is no transition for Q2 from B, so there will not be nothing here. So epsilon closure of Q1, epsilon closure of Q1 is Q1 Q2. So this is Q1 Q2. So delta Q1 Q2 on B goes to Q1 Q2. It means what? Q1 Q2 Q1 Q2. So this will be a self loop. As I explained in the basic video, name of the states you can give anything. Like here Q0 Q1 Q2, you can give A B C or Q0 Q1, anything you can give, that doesn't matter. Similarly, find it out transition for C now. Q1 Q2 reading C. You can find it out, and that will be transition for C. So Q1 reading C, there is no transition for C from the Q1. Q2 reading C, self loop, it's going to Q2 itself. Epsilon closure of Q2 is Q2 itself. It means what? Q1 Q2 state reading symbol C going to Q2. So going to Q2. This way we have transition for A, B and C from the Q1 Q2 state. Now what is the new subset here? Subset is Q2. So repeat the same process for Q2 also. So delta Q2 on reading A. Let me rewrite this. On symbol A. From Q2 we need to find out transition for ABC. So Q2 on A. From Q2 there is no transition for A. So it will be what? Phi. So Q2 is going for transition for A. It's going to dead state. Repeat the process for B. Q2 on B. If we see the existing epsilon NFA, there is no transition for B also. So it will also goes to phi. Epsilon closure of phi is phi. It's a dead state. It means what? From Q2, transition of A and B going to dead state. Similarly, repeat for C. Q2 on C. So Q2 state reading C symbol going to where? Self loop. It's going to Q2. What is the epsilon closure of Q2? It's Q2 itself. So delta Q2 on C going to Q2. It means what? Self loop. It's going to self loop. If you observe, we have transition from Q2 for symbol A as well as B as well as C. And there are no new subsets are created. If you think about this dead state we always have transition for all the symbols. If you see the previous recordings for DFA, I have explained this. Dead state means once automata is in the dead state, it will go nowhere. We can directly give the transition for all the input symbols. This is the final DFA. This only one thing is remaining. What is the final state here? The way I told you while conversion of NFA to DFA, same process you need to follow here. For example, in the existing NFA, epsilon NFA, what is the final state? It's a Q2. So in this DFA, wherever is Q2, for example, Q0, Q1, Q2, so wherever Q2 is present, that state becomes the final state. So make this final. Here also Q2, make this final. Q0, Q1, Q2 becomes final. Here also Q2 separately, so this also becomes finals. So all this state becomes final state. In this way, you can convert this epsilon NFA to final DFA. You can first find out epsilon closure, and using this simple step, delta, you can take the new subset and epsilon closure, write down the same thing here as it is and find it out. Epsilon closure already we have in this table, we can use it. If you want, not in the exam, but if you want, you can redraw this diagram just for the better understanding. How many states are there? There are 3 states plus 1, it's a 1 dead state. And if you want, you can give any other name to these states. It's not required, you can keep this as a Q0, Q1, Q2. If you want, you can give the other names, like you can give state A, you can give the name state B, or you can give the name state C. All are final, so you can make it as a final. This step is not required, but if you want, just for good look and feel, you can give the names like this. Then what are the transitions? A having the self loop for A, B having the self loop for B, similarly here self loop for C. A having transition for B, then transition for C, this transition is for C, and then remaining transitions for dead state, and this becomes your final answer. Dead state having self loop for all the symbols. If you observe here, from each state there is a transition for each symbol. That's what our deterministic nature. From B, transition for each symbol. For C, same process. Okay, and this is our final DFA, and in this way you can convert epsilon NFA to DFA. In the next session we will see one more example of conversion of epsilon NFA to DFA. Thank you for watching.